July 18, 1944. A field near Hamarøy municipality, northern Norway. The Vought F4U Corsair touched down hard on uneven ground, its distinctive inverted gull wings rocking as Lieutenant Matoli fought to bring the wounded fighter under control. The engine coughed, sputtered, then fell silent. Technical problems, the kind that ended missions and changed fates, had forced this emergency landing far from HMS Formidable, the British carrier steaming somewhere to the west. The Corsair, serial number JT-404, belonging to 1841 Naval Air Squadron, sat intact in Norwegian soil, now under German control. Within hours, Wehrmacht salvage teams arrived. They photographed the aircraft from every angle, measured dimensions, and examined the massive Pratt & Whitney R-2800 double Wasp engine. This was the fighter the Japanese called Whistling Death, the aircraft that dominated Pacific skies with an 11-to-1 kill ratio, a machine capable of exceeding 400 miles per hour faster than anything currently flying in Luftwaffe service. The Germans desperately wanted to test it, to understand what American engineering had created, to learn its strengths, exploit its weaknesses, and share that knowledge with fighter pilots defending an increasingly battered Reich. But Lieutenant Matoli, now a prisoner of war, refused to cooperate with one critical detail. He would not explain how to fold the Corsair's wings for transport. The aircraft was far too large to move by road without wing folding. The Germans tried everything: threats, promises, technical diagrams. The British pilot remained silent. This single act of defiance would trigger a cascade of failures that revealed something far more significant than the capabilities of one fighter aircraft. JT-404's journey from that Norwegian field to Erprobungsstelle Rechlin, Germany's primary aviation testing facility, would expose the widening gap between American industrial might and Germany's collapsing technical infrastructure in the summer of 1944. The Corsair represented American aerospace engineering at its finest, but Germany's inability to make it fly would demonstrate something even more profound about the mathematical certainty of Allied victory and the terminal decline of the Thousand-Year Reich. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The F4U Corsair that sat immobilized in that Norwegian field represented the culmination of American fighter design philosophy in 1940. When the United States Navy issued its specification for a carrier-based fighter in 1938, it demanded performance that seemed almost impossible to achieve. Maximum speed, heavy armament, long range, carrier compatibility. Vought Aircraft Corporation responded with an audacious design built around the most powerful engine available, the 2,000 horsepower Pratt & Whitney R-2800 double Wasp. This 18-cylinder radial engine was a masterpiece of American engineering. It produced more power than any fighter engine then flying in Europe. But that enormous power created an immediate problem. The engine required a massive 13-foot diameter Hamilton Standard hydromatic propeller to efficiently convert horsepower into thrust. No conventional landing gear design could provide sufficient ground clearance for such a propeller without creating impossibly tall, structurally weak struts that would collapse under carrier landing stresses. Vaught's solution became the Corsair's most distinctive feature: inverted gull wings that angled sharply downward from the fuselage before leveling out toward the wingtips. This configuration raised the engine and propeller high enough for ground clearance while allowing relatively short, robust landing gear perfectly suited for violent carrier deck landings. The bent wing design also reduced drag at the wing fuselage junction, improving aerodynamic efficiency across the entire speed range. On May 29, 1940, test pilot Lyman Bullard lifted the prototype XF4U-1 into the air for its maiden flight. 4 months later, on October 1st, that same prototype became the first single-engine American fighter to exceed 400 miles per hour when it averaged 405 miles per hour on a test flight from Stratford to Hartford, Connecticut. This performance stunned both American and foreign observers. The Corsair was faster than anything flying in Europe except experimental prototypes. Its speed advantage over the Messerschmitt Bf 109 and Focke-Wulf FW-190 exceeded 40 miles per hour, a massive margin that would prove decisive in combat. But speed was only part of the story. The R-2800 engine's tremendous power delivered exceptional climb rate and altitude performance. The Corsair could reach over 36,000 feet, where thin air degraded the performance of European fighters equipped with less sophisticated supercharger systems. Its combat ceiling exceeded that of every German fighter, except experimental high-altitude interceptors that never entered large-scale production. Range capabilities transformed strategic air warfare over the Pacific. Standard internal fuel capacity provided over 1,000 miles of range. With external drop tanks, mission duration could exceed 8 hours. American pilots could escort heavy bombers throughout entire missions deep into enemy territory, eliminating the tactical window that German fighter pilots had exploited earlier in the war, when shorter-range escorts had to turn back before reaching target areas. The aircraft's armament reflected American firepower philosophy. 650 caliber Browning M2 machine guns, 3 mounted in each outer wing panel, delivered devastating concentrated fire. Each gun carried over 300 rounds of ammunition, allowing sustained engagement, without the ammunition exhaustion that plagued German fighters equipped with heavier caliber but ammunition-limited cannon. Later variants would mount 4 20mm cannon, providing even greater destructive power against both air and ground targets. The Corsair could also carry bombs and rockets, transforming from air superiority fighter to ground attack aircraft without modification. Production of the Corsair began in 1942. By July 1944, when JT-404 made its forced landing in Norway, American factories had delivered thousands of F4US to Navy, Marine Corps, and Fleet Air Arm squadrons. 3 manufacturers, Vought, Goodyear, and Brewster, produced Corsairs simultaneously, using standardized drawings and fully interchangeable components. This mass production capability, fundamental to American industrial strength, remained largely beyond German capacity throughout the war. German aircraft production relied on relatively small workshops employing skilled craftsmen who built airframes with significant variation between individual examples. Parts interchangeability, routine in American practice, was more theoretical aspiration than operational reality in German aviation. The British Fleet Air Arm, which operated JT-404, had embraced the Corsair enthusiastically despite initial American Navy reluctance to deploy it aboard carriers. Early Corsairs exhibited challenging carrier landing characteristics. The long nose created poor forward visibility during landing approaches. The aircraft tended to bounce on touchdown. Wing, stall characteristics at slow approach speeds proved unforgiving. The United States Navy initially assigned Corsairs to land-based Marine Corps squadrons, while deploying the more docile Grumman F-6F Hellcat aboard carriers. Marine pilots flying from Pacific Island airstrips demonstrated the Corsair's extraordinary combat effectiveness, achieving kill ratios that exceeded 11-to-1 against Japanese aircraft. British carrier pilots solved the landing problems through modified approach techniques and carrier procedures. They demonstrated that proper training and technique made Corsair carrier operations not just feasible but highly effective. Armed with this knowledge, the United States Navy finally cleared the F4U for American carrier operations in late 1944. By mid-1944, Fleet Air Arm Corsair squadrons operated from British carriers throughout multiple theatres. HMS Formidable carried 18 Corsairs from 1,841 Naval Air Squadron, the unit to which JT-404 belonged. These aircraft participated in Operation Mascot, a carrier strike against the German battleship Tirpitz, anchored in Kafjord, Norway. Tirpitz represented an existential threat to Allied Arctic convoys supplying the Soviet Union. The massive battleship, sister ship to the infamous Bismarck, could break out into the Norwegian Sea and devastate convoys protected only by cruisers and destroyers. British carrier forces had attempted multiple strikes against the battleship throughout 1944, launching waves of Fairey Barracuda dive bombers escorted by Corsairs and other fighters. Operation Mascot launched on July 17, 1944. The strike force departed from 3 carriers, Formidable, Indefatigable, and Furious, escorted by the battleship HMS Duke of York, 4 cruisers, and 12 destroyers. Admiral Moore commanded from Duke of York. The carrier group was led by Rear Admiral Roderick McGrigor aboard Indefatigable. Formidable's air group included 24 Barracuda torpedo bombers from 827 and 830 Naval Air Squadrons, plus 18 Corsairs from 1,841 Squadron, providing fighter escort and ground attack support. The strike aircraft launched in the early morning hours, flying through Norwegian coastal waters toward Kafjord. German radar detected the incoming raid while aircraft were still en route. By the time British planes arrived over the target, smoke generators had completely obscured Tirpitz beneath an impenetrable artificial fog. Few pilots could identify the battleship through the smoke screen. Bomb and rocket attacks achieved no significant damage. German flak batteries shot down several British aircraft. The operation was a tactical failure, demonstrating that Barracuda dive bombers were too slow to achieve surprise against heavily defended targets. But one consequence would prove significant for aviation history. JT-404, flying in company with a Fairey Barracuda, developed mechanical problems during the return flight to Formidable. Lieutenant Matholi recognized immediately that reaching the carrier was impossible. The engine was failing. The fuel situation was critical. Norwegian coastline stretched below territory firmly under German control since the 1940 invasion. He had 3 choices. Ditch in the North Atlantic, where survival time in frigid water measured in minutes, attempt to reach neutral Sweden, hundreds of miles distant with a dying engine, or execute a controlled crash landing and accept capture. Matholi selected a field near Hamarøy, north of Bodo. The Corsair came down hard but intact. The pilot survived without serious injury. German forces reached the site within hours, securing both pilot and aircraft before any possibility of destruction or Allied recovery. Wehrmacht intelligence officers interrogated Matholi extensively. They wanted technical information about the Corsair's systems, performance characteristics, and operational procedures. Most critically, they needed to know how to fold the wings so the aircraft could be transported to Rechlin for comprehensive testing. The Corsair's wing folding mechanism was essential for carrier operations. Deck space aboard carriers was extraordinarily limited. Aircraft needed to fold to allow maximum numbers to be stored below decks and spotted on the flight deck. The F4U's wings folded upward at a hinge point near the inverted gull wing's angle, reducing the aircraft's span from 41 feet to just 17 feet. This folding system was entirely hydraulic and required specific knowledge to operate safely. Forcing the mechanism without proper procedure could cause catastrophic structural damage. Matholi understood this perfectly. He also understood that German engineers would eventually figure out the system through examination, but every hour of delay reduced the likelihood of successful testing. The British pilot refused all cooperation regarding wing folding procedures. German interrogators attempted persuasion, threats, and various psychological pressure tactics documented in Luftwaffe prisoner handling protocols. Matholi remained silent on this specific technical detail. Unable to fold the wings, German salvage teams faced a transportation challenge. The Corsair was too wide to move by road or rail without extreme difficulty. They ultimately loaded the entire aircraft onto a boat and ferried it by water for initial investigation, likely to Narvik, where facilities existed for handling large military equipment. Eventually, the Corsair reached Germany. Records indicate JT-404 arrived at Erprobungsstelle Rechlin, the Luftwaffe's central aircraft testing facility, sometime in summer 1944. Official documentation listed the aircraft as under repair for 1944, a status that would never change. Rechlin represented Germany's most sophisticated aviation testing infrastructure. Located approximately 100 kilometers northwest of Berlin in Mecklenburg, the facility had served as the Luftwaffe's primary evaluation center since February 26, 1936, when Reich War Minister Werner von Blomberg officially designated it the Luftwaffe's testing ground. The facility sprawled across multiple airfields and technical complexes. The main airfield featured a roughly hexagonal perimeter road, defining a massive grass field. approximately 1,700 meters across. No hard surface runways existed at the main facility. Aircraft operated from turf like most pre-war aerodromes. A second facility at nearby Laz included concrete runways suitable for heavier aircraft and higher speed operations. Rechlin's mission encompassed comprehensive testing of all new German aircraft designs and captured Allied types. Test pilots evaluated performance, handling characteristics, and combat effectiveness. Engineers measured speed, climb rate, service ceiling, range, and fuel consumption. Technicians examined construction methods, materials, and manufacturing techniques. Weapons specialists tested armament systems and munitions effectiveness. The facility included specialized departments for engines, weapons, radio equipment, navigation systems, and virtually every other aviation technology. Wind tunnels, test cells, workshops, laboratories, and administrative buildings supported an operation employing thousands of personnel at peak strength. Rechlin's datasheets on both Luftwaffe and captured Allied aircraft are considered by aviation historians to be among the most reliable sources for World War II aircraft performance data. The testing protocols were rigorous, systematic, and scientifically sound. German engineers approached evaluation with professional thoroughness that produced detailed technical reports circulated throughout Luftwaffe command structure. By summer 1944, Rechlin had evaluated numerous captured Allied aircraft. American P-38 Lightnings, P-47 Thunderbolts, and P-51 Mustangs had all undergone comprehensive testing. British Spitfires, Mosquitoes, and Lancasters sat in various states of repair around the facility. Soviet aircraft captured on the Eastern Front provided intelligence about Russian capabilities. The captured aircraft program served multiple purposes beyond pure intelligence gathering. Test flights allowed German pilots to experience enemy fighters firsthand, understanding their strengths and limitations through direct comparison with Luftwaffe types. This knowledge transferred to frontline units through training programs and written reports. The Wonder Circus Rosarius traveling circus took captured aircraft to operational fighter bases across Germany and occupied territories. Under command of Theodor Rosarius, this specialized unit demonstrated enemy aircraft capabilities to frontline pilots, allowing them to observe, examine, and in some cases fly against captured types in mock combat. These demonstrations provided invaluable tactical intelligence. German pilots learned to recognize characteristic sounds, visual signatures, and maneuver patterns of Allied aircraft. They identified optimal engagement parameters and developed counter-tactics exploiting specific weaknesses. Most importantly, they gained realistic assessment of enemy capabilities, replacing propaganda-influenced assumptions with empirical knowledge. JT-404 should have been perfect for this program. The Corsair represented American fighter technology at its apex, exactly the kind of aircraft German pilots needed to understand. Its performance exceeded that of every German fighter in critical areas. Its combat record in the Pacific demonstrated devastating effectiveness. Luftwaffe fighter pilots desperately needed accurate intelligence about Corsair capabilities as American forces pressed from multiple directions. But the Corsair never flew at Rechlin. It never participated in Wonder Circus demonstrations. It never provided the tactical intelligence German commanders so urgently required. Instead, it sat under repair throughout its time at the facility, a status indicating work in progress that would never reach completion. The reason JT-404 never flew at Rechlin tells a story far larger than one captured aircraft. It reveals the systematic collapse of German technical and industrial capacity during the summer and fall of 1944, a collapse that no amount of tactical skill or individual courage could reverse. The contrast with other captured American fighters tested at Rechlin demonstrates how dramatically Germany's situation had deteriorated. When German salvage teams recovered a Republic P-47 Thunderbolt near Cayenne in November 1943, technical staff at Rechlin repaired it to flying condition within weeks. Test pilot Walter Wolfram flew that P-47 extensively, later describing the immense cockpit and impressive dive performance in detailed reports that circulated through Luftwaffe command structure. When a North American P-51 Mustang crashed in northern France on D-Day the same day, Lieutenant Matherly was attacking Tirpitz. German technicians restored it to airworthiness and delivered it to the Wanda Zirkus Rosarius for demonstration flights across multiple fighter bases. German pilots flew that Mustang until its loss in December 1944. The P-47 testing occurred in late 1943. The P-51 capture happened in June 1944. JT-404 arrived at Rechlin in mid-summer 1944. 8 months separated the successful P-47 evaluation from the Corsair that would never fly. Those 8 months witnessed the final disintegration of Germany's industrial war machine. In May 1944, Albert Speer, Reich Minister of Armaments and War Production, told Adolf Hitler that Allied bombers had struck Germany at one of its weakest points by targeting synthetic oil production. Speer warned that if attacks continued, Germany would soon have no fuel production worth mentioning. Wikipedia captured. Wings Wiki American bomber raids on May 12 against the synthetic fuel plants at Leuna, Lützgendorf, Berlin, Seitz, and Brooks reduced German fuel production to 56% of capacity. The highest production achieved in 1944 was in May, with approximately 170,000 tons of high-grade aviation fuel produced, including Romanian imports from Ploiești, U.S. Navy history. Those May attacks occurred just 6 weeks before JT-404's emergency landing in Norway. The strategic bombing campaign against German oil infrastructure would intensify throughout summer and autumn, throttling fuel supplies that Luftwaffe operations absolutely required. Total German oil production and imports dropped from 918,000 tons per month in the first quarter of 1944 to 319,000 tons in the last quarter, a decline of 2/3, caused primarily by attacks from strategic air forces. Vought. The fuel shortage devastated every aspect of Luftwaffe operations. Pilot training time was slashed dramatically. New fighter pilots arrived at operational units with minimal flight experience, sometimes barely 100 total hours, compared to the 200 to 400 hours American pilots received. Advanced training in instrument flying, formation procedures, and combat tactics was eliminated or severely curtailed, as aviation fuel became too precious to allocate for training purposes. Operational units husbanded their dwindling fuel supplies carefully, measuring every mission against available reserves. Testing captured aircraft, an activity that consumed substantial quantities of fuel for repeated evaluation flights, fell to lower priority as fuel became increasingly scarce. But fuel shortage was merely the most visible symptom of broader industrial collapse. In late summer 1944, German records listed 7.6 million foreign civilian workers and prisoners of war in German territory, most brought there by coercion. Slave labor made up 1/4 of Germany's entire workforce, and the majority of German factories employed contingents of prisoners. Fandom. There were 7 million foreign workers in the Reich in 1944, supplementing a German workforce consisting mostly of women and those men who were too old to serve in the military or whose skills were valued too highly for conscription. The foreign workers were almost all forced laborers badly paid and effectively imprisoned. Simple planes. The quality implications for aircraft production and maintenance were catastrophic. Captain Dieter Lukesch, who commanded the first operational Arado R-234 jet bomber squadron, remarked about production quality of brand-new aircraft his unit received in July 1944. Hardly any aircraft arrived without defects which covered all systems and were caused by hasty completion and shortage of skilled labor at the factories. Silver Hawk author, German aircraft factories, once staffed by skilled craftsmen who took pride in their work, now relied increasingly on forced laborers who had every reason to sabotage production and no incentive to maintain quality. Components were assembled incorrectly. Foreign objects were deliberately left in fuel systems and oil passages. Fasteners were improperly torqued. Electrical connections were left loose. The Corsair sitting at Rechlin required more than simple repairs. It needed comprehensive restoration by skilled technicians familiar with American aircraft systems, using specialized tools and genuine spare parts that could only come from American supply chains. German maintenance personnel, increasingly composed of inadequately trained workers and forced laborers with minimal expertise, lacked the knowledge base to properly restore such a complex foreign aircraft. American aircraft design philosophy differed fundamentally from German approaches in ways that created additional obstacles. The Corsair's hydraulic wing folding mechanism, its sophisticated R2800 engine with its complex ignition and fuel systems, its electrical systems operating on different voltage standards, every aspect required specific knowledge that German technicians did not possess. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Recklin's testing facility itself faced mounting operational challenges throughout summer and autumn 1944. Allied strategic bombing targeted German aviation infrastructure with increasing effectiveness. While Recklin's remote location northeast of Berlin provided some protection, the facility could not entirely escape the deteriorating situation affecting all German military installations. Transportation networks collapsed under sustained Allied air attack. The United States Strategic Bombing Survey identified consequences of the breakdown of transportation resulting from attacks against transportation targets as probably greater than any other single factor in the final collapse of the German economy. Captured Wings Wiki. Moving aircraft, components, fuel, and personnel between facilities became progressively more difficult as railways, bridges, and roads were systematically destroyed. The intellectual capital required for sophisticated aircraft testing was hemorrhaging. Experienced engineers and test pilots were increasingly scarce. Some were conscripted for military service as manpower shortages intensified. Others died in Allied bombing raids or were killed in flying accidents as operational tempo increased and safety margins decreased. Those who remained faced overwhelming workloads evaluating German aircraft designs, while the entire industrial infrastructure crumbled around them. Testing new German aircraft took absolute priority over examining captured enemy types. The Messerschmitt Me 262 jet fighter, finally entering operational service after years of delayed development, required extensive evaluation to address persistent engine reliability problems. The Arado R-234 jet bomber needed testing despite the quality control issues Captain Lukesch had identified. Various rocket-powered interceptor prototypes demanded assessment even as they demonstrated impractical combat characteristics. German engineers faced a grim calculus. They could allocate scarce resources, fuel, skilled labor, testing time to understanding enemy aircraft whose capabilities they already recognized from combat reports. Or they could focus those same resources on German designs that might conceivably offer some tactical advantage if technical problems could be solved and production ramped up. The Corsair represented valuable intelligence, certainly, but intelligence about American capabilities could not reverse Germany's strategic position. German fighter pilots desperately needed reliable aircraft with adequate fuel supplies and proper maintenance support. They needed realistic training time and survivable odds. Understanding Corsair performance characteristics in detail would not provide any of these critical requirements. So JT-404 sat at Rechlin under repair, a status that acknowledged the aircraft's presence, while tacitly admitting that restoration to flight-worthy condition was impossible given available resources. The paperwork listed it officially. Engineers probably examined it periodically. Perhaps they photographed it, measured dimensions, documented construction details visible through cursory inspection, but comprehensive flight testing never occurred because German technical capacity in mid-1944 could not support such efforts. What German pilots missed learning about the Corsair would have shocked them had they experienced it firsthand. Just as P-47 and P-51 testing had revealed uncomfortable truths about American engineering sophistication, the Corsair's performance envelope exceeded that of virtually every German fighter in production or development. A maximum speed of 450 miles per hour officially measured in testing made it faster than the Messerschmitt Bf-109G by more than 60 miles per hour, faster than the Focke-Wulf FW-190A by 70 miles per hour, even faster than the Focke-Wulf FW 190D Dora, the improved inline engine variant specifically developed for high-altitude performance, which could reach 426 miles per hour under optimal conditions. The R2800 engine's tremendous power, 2,000 horsepower, compared to 1,475 horsepower for the DB 605 engine in late-model BF 109 seconds, provided climb performance that German fighters could not match. The Corsair could reach 10,000 feet in under 3 minutes, 20,000 feet in under 6 minutes, 30,000 feet in under 11 minutes. These climb rates exceeded German fighter capabilities across the entire altitude range. A combat ceiling of nearly 40,000 feet placed the Corsair far above the effective operational altitude of German fighters equipped with single-stage superchargers. The German pilots who encountered Corsairs in combat primarily over Norway during carrier strikes against Tirpitz reported frustration at the American fighters' ability to climb away from engagement, leveraging superior power and altitude performance to dictate combat terms. The aircraft's structural strength would have impressed German engineers who examined captured examples. Like the P-47 Thunderbolt, the Corsair was massively built with safety margins that far exceeded German design philosophy. It could sustain battle damage that would destroy lighter German fighters and still return to carrier operations. Dive performance rivaled that of the P-47, a characteristic German pilots had found particularly troubling. The Corsair could dive at extremely high speeds without encountering the severe control stiffening that plagued German fighters approaching or exceeding their maximum design speeds. Pilots could pull out of steep, high-speed dives without excessive physical effort, and the airframe remained stable throughout, without tendency toward flutter or structural failure. Range capabilities demonstrated American engineering priorities that German designers had never emphasized. The Corsair carried substantially more internal fuel than any German fighter. With external drop tanks, mission duration could exceed 6 hours, more than 4 times the endurance of BF 109 seconds, or standard FW 190 variants. This extraordinary range enabled carrier operations far from their task forces and provided tactical flexibility impossible for German fighters tethered to bases by limited fuel capacity. The wing design, that distinctive inverted gull configuration, provided more than just ground clearance for the massive propeller. The configuration reduced parasitic drag at the wing fuselage junction while maintaining structural efficiency. The wings could fold upward hydraulically, reducing span from 41 feet to 17 feet for carrier storage. This folding mechanism, which had so frustrated German interrogators, demonstrated sophisticated hydraulic engineering and robust mechanical design that German aircraft rarely incorporated. Armament reflected American firepower philosophy evolved through Pacific combat experience. 650 caliber Browning machine guns delivered concentrated fire with ample ammunition capacity. Some variants mounted 4 20mm cannon for even greater destructive effect. The Corsair could also carry bombs and rockets, providing ground attack capability without modification. This versatility, transitioning seamlessly from air superiority fighter to ground attack aircraft, demonstrated design flexibility that German aircraft rarely achieved. The cockpit layout, visible through the canopy even in JT-404's grounded state, reflected thoughtful ergonomic design. Controls were logically arranged and positioned within easy reach. Instruments were clearly marked and sensibly grouped by function. The seat provided substantial support and comfort for extended missions. Visibility, though restricted somewhat by the long nose ahead of the pilot, exceeded that of the BF 109 significantly. Most importantly, the Corsair represented proven combat effectiveness. By July 1944, Marine Corps and Fleet Air Arm squadrons had demonstrated the aircraft's devastating capabilities through hundreds of successful combat missions. The Japanese had learned to fear the distinctive sound of the Corsair's R2800 engine, giving it the nickname Whistling Death in recognition of its lethal effectiveness. American pilots flying Corsairs had achieved kill ratios exceeding 11-1 against Japanese aircraft statistics that reflected not just pilot skill, but the fundamental superiority of the aircraft they flew. The Corsair could engage on its own terms. using speed and climb advantages to dictate combat geometry. It could disengage when threatened, accelerating away from pursuit. It could sustain battle damage and still complete missions. None of this intelligence reached Luftwaffe pilots through systematic evaluation because the aircraft never flew at Rechlin. German fighter pilots defending against Allied bomber formations over the Reich, struggling with inadequate fuel supplies and deteriorating aircraft quality, faced American escorts without understanding the full extent of their disadvantage. The captured Corsair became a symbol of lost opportunity, not because testing it would have changed strategic outcomes, but because Germany's inability to perform such testing demonstrated how completely its technical infrastructure had collapsed. Just 18 months earlier, German engineers had routinely restored captured enemy aircraft to flight-worthy condition and conducted comprehensive evaluations that produced detailed technical reports. Now they could not even make one intact aircraft airworthy despite possessing the physical machine. The final disposition of JT-404 remains unclear from surviving records. The aircraft was almost certainly destroyed during the final months of the war. Perhaps it burned when Rechlin was evacuated ahead of advancing Soviet forces in early 1945. Perhaps Allied bombers destroyed it during raids against the facility. Perhaps retreating German forces demolished it deliberately to prevent recapture. The specific fate matters less than what its capture and abandonment revealed about Germany's terminal decline. An intact operational example of America's most advanced carrier fighter had fallen into German hands at a moment when intelligence about enemy capabilities remained desperately important. Yet Germany proved incapable of extracting that intelligence despite possessing the physical aircraft, the testing facilities, and theoretical expertise required. This failure reflected industrial and technical collapse far more profound than simple resource shortages. Germany had entered World War II with significant advantages in many technologies and tremendous confidence in its engineering capabilities. By mid-1944, it could not perform tasks repairing and testing captured aircraft that had been routine just months earlier. German insiders credited the Allied bombing offensive with crippling German war industry. Speer repeatedly said both during and after the war that bombing caused crucial production problems. War relics. The cumulative effects of strategic bombing, chronic resource shortages, forced labor quality problems, and systematic destruction of transportation infrastructure had created a downward spiral from which recovery was impossible. The Corsair that Germany captured but could never fly stands as a monument to industrial superiority, as decisive as any combat victory. American factories produced more than 12,000 F4U Corsairs during the war, maintaining consistent quality despite enormous production volumes. These aircraft equipped dozens of squadrons across multiple theaters, supported by comprehensive logistics networks that provided spare parts, maintenance expertise, and operational support. German aviation could not match this industrial performance. German aircraft production increased as spare capacity in the industry was used and dispersal of production increased resilience, but the effective combat strength of the Luftwaffe did not increase despite large numbers of aircraft available. MilitaryHistoryNow.com. Aircraft sat grounded awaiting fuel that never arrived, repairs that could not be completed with available parts and labor, or pilots who had been killed faster than replacements could be trained. The mathematics were brutal and inescapable. America could produce thousands of Corsairs, maintain them properly, fuel them adequately, and train pilots thoroughly to extract maximum performance. Germany could capture one Corsair, but lacked capacity to make it fly. This disparity, multiplied across every dimension of industrial warfare, determined outcomes more certainly than tactical brilliance or individual heroism possibly could. JT-404's story parallels the broader trajectory of German fortunes during 1944. Early in the year, Germany still possessed theoretical capability to test captured aircraft, train pilots adequately, and maintain reasonable aircraft availability rates. By summer, fuel shortages were critical. By autumn, transportation networks were collapsing. By winter, even basic maintenance had become problematic, as spare parts vanished and skilled labor disappeared into the meat grinder of total war. The Corsair arrived at Rechlin at precisely the moment when Germany's ability to conduct sophisticated testing had evaporated. It represented knowledge Germany desperately needed but could no longer obtain. It stood as physical evidence of American industrial and engineering capabilities that German propagandists had spent years claiming were inferior to German achievements. Most painfully, it demonstrated that understanding American advantages intellectually could not overcome the fundamental resource disparities driving Allied victory. German engineers recognized that American aircraft were well designed, well built, and highly effective. This knowledge changed nothing about Germany's ability to counter those aircraft with adequate numbers of competitive German fighters flown by properly trained pilots with sufficient fuel and maintenance support. The captured Corsair that never flew tells a story about industrial warfare's inexorable logic. Production capacity matters, logistics infrastructure matters, skilled labor matters, resource access matters, training capacity matters. These factors, multiplied across entire economies and sustained over years of total war, determine outcomes far more reliably than individual weapon performance or tactical innovation. Germany had entered the war believing that superior technology and tactical doctrine could overcome material disadvantages. The Corsair sitting useless at Rechlin in late 1944 proved that belief catastrophically wrong. Superior technology meant nothing if you lacked industrial capacity to produce it in adequate quantities. Tactical doctrine meant nothing if you lacked fuel to train pilots properly and support operations. Engineering excellence meant nothing if your factories employed forced laborers with every incentive to sabotage production. By December 1944, as German forces launched their desperate Ardennes offensive with carefully hoarded fuel reserves, the contrast between German and Allied capabilities had become undeniable. German ground troops literally ran out of oil during the Battle of the Bulge. By February 1945, most remaining German aircraft, including jet-powered Messerschmitt Me 262 seconds, were pinned to the ground by lack of fuel. Vought. The war ended 5 months after that final fuel crisis with Germany's unconditional surrender. Allied forces advancing through Germany discovered thousands of aircraft, many brand new, sitting abandoned on airfields across the collapsing Reich. They found factory complexes producing components that could never be assembled. They found maintenance depots without spare parts, training facilities without fuel, and combat units without pilots. Among the discoveries was likely JT-404, if it had survived that long. Perhaps some Allied intelligence officer examined the Corsair, noted its German markings and identification codes, documented its presence at Rechlin, and filed a report. Perhaps it had already been destroyed by then, consumed in the general conflagration as Allied armies converged from east and west. The specific fate of one aircraft hardly matters compared to the larger truth its story reveals. America's industrial economy, mature automotive technology, comprehensive logistics networks, and enormous resource base proved decisively superior to German engineering sophistication and tactical skill. The United States could produce 12,000 Corsairs. Germany could not make one captured example fly. This fundamental disparity in industrial capacity translated into military power determined World War II's outcome as certainly as any battle or campaign. The Corsair Germany captured but could never fly stands as perfect symbol of that industrial supremacy and the terminal collapse of German technical capability in the face of overwhelming Allied material advantage. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.